Yeah. When you do common base, if I have like 2 to the smiley face equals 2 to the 6, what would be true then about smiley face? It equals 6, right? If you have 2 to a smiley face equals 2 to the 6, then you would tell me then that smiley face equals 6, because that would be a true statement, right? So we're always trying to make common bases, because if you make the bases common, we can say that the exponents then have to be equal. So if I had like 2 to the 4 equals 2 to the m, what would m have to be? 4, right? So if we make these the same, then we can say that our exponents then therefore need to be the same. So that's why we're always making our bases be the same. And we're always making our bases be the same, but smallest. So like, if I could make 2 be 64, I'm not going to do that. I'm going to make 64 be base 2. I'm always making them be smaller bases, right? So down here I have 9 to the 3x plus 1 equals 27 to the 3x. What base can I make 9 and 27 both be? 3. So I can make 9 be 3 to the what? 3 to the 2. And then that's to the 3x plus 1. And then 27 is 3 to the what? 3 to the 3. To the 3x. Then I need to remember to distribute, right? And what happens where the errors happen on tests is people will forget to distribute that 2 to the 1. Do you see how this, do you remember to do it to the 3, but everyone forgets to distribute it to the 1? So that's why I'll often put it in brackets, is so that you remember to put the 3 to the 2 and the 1 to the 2. So we have 3 to the 2 times 3x, which is 6x, and then 2 times 1, which is plus 2. And then we have 3 to the 3 times 3x, which is 9x. Now, if we had 3 to the smiley face equaled 3 to the 4, smiley face would equal 4. That was a true statement you told me, right? So, if I have 3 to the 6x plus 2 equals 3 to the 9x, what would you then tell me?
6x plus 2 equals 9x.
6x plus 2 must equal 9x. So that's why you're not writing the base anymore. It's not because you cross the base off. It's not because the base explodes and goes away. It's because if this is the same base as this, then my exponents must equal. So my next step is to just say, okay, well then 6x plus 2 must have to equal 9x if they're the same base. Now when you have two x's, you can solve it either way to make your x's be on the same side. But you need to get your x's together when you have more than one. This is the page number. So I'm going to take my 6x and move it over to my 9x. But technically, if you move the 9x to the 6x, you wouldn't be wrong. You're just making more steps for yourself. But you do need to get, if you have more than one x, one on one side, one on the other, that's the first thing you need to do. You need to get those babies together. Okay? So I'm going to move the 6x. How am I going to move it? Divide by 6x. And by divide, I mean subtract. Subtract 6x. So I get 2 equals 9x minus 6x is 3x, and then I divide by 3. So I get the x by itself. So I get x equals 2/3. Okay, everyone go to their calculators. Y1 is 9 to the 3x plus 1. If you have the older calculators, you need to put in brackets. And y2 is 27 to the 3x. Y1, Y2. Yeah.
Sorry, what do you put on Y2? The 27.
Yeah, just the left. So the left-hand side goes in one y equals, the right-hand side goes in the other. So it's just this and this. Now, your window only needs to make sure that you can see the x value. So my x is 2/3, right? Which is a little less than 1. Does 2/3 fit between negative 10 and 10? Caleb? Does 2/3 fit between negative 10 and 10?
Yeah.
Yeah. Yeah, it does. I'm just staring at you because I don't know what you're doing. Oh, you were doing that. You had me confused. I thought you were doing, like, you were just dazed is what I thought. But it was your calculator.
Yeah.
I didn't think you had a calculator. Did you borrow one?
I did.
Ah,
Yeah.
therein lies the issue.
Yeah.
I wasn't here when he borrowed one.
Yeah.
Okay, so 2/3 fits between negative 10 and 10. Yes? So we should be able to find it. It doesn't matter if we're at y max of 100 or y min. It doesn't even matter if you can't see where they intersect, actually. It's kind of funny. As long as your x value shows up. So if my x answer, if I solved it out and my x was 20, would a negative 10, 10 window work if x was equal to 20? No, I would have to make my x at least bigger in order to find it. Okay? So what do we do next once we have this? How do we solve for it? What do we do? Second, and what? Trace, 5, enter, enter, enter. Now what do you get? You get a decimal, correct? Do this. Go out of your screen. I hope every single person found this so you can practice it. So you just found an answer as x and it's a decimal. We agree? So go second mode. Get out of that screen. Second mode gets you to quit and puts you to the main screen, right? Then press X, enter. What shows up on your main screen? The answer that you just found, doesn't it? X, enter. So every single time you find a new intersection, that x is going to change. It's going to be whatever the heck it is. So if you go and you find an x and it's a decimal, and it possibly could change to a fraction, what you can do is you can go second mode, you go to your main screen, and you press X, enter, and a decimal shows up, right? How do you turn decimals into fractions? Math, enter, enter. So press math, enter, enter, because math frac, right? What does it turn it to? Does it match? Yes, we're good. Okay, then we're going to go to the next page. Now, Mrs. E asked you to do the questions for homework. You might say, well, how do I know if I did them right? How can you check your answers? With your calculator. Y1, Y2. We just did it, didn't we? Y1, Y2. So could you check all your answers of what you just did for homework? Yes, you should know if you got them right or you didn't. It either matches or it does not. And if you didn't get them right, you need to come in and ask questions. Okay? All right. This one here, we have 2 times 4 to the x plus 2 equals 32. Okay? This is leading you into some type of word problems as we get to them. But a lot of people will do this. They'll tell me this is 8 to the x plus 2. You cannot do that. You cannot make the 2 and the 4 join. If the 4 has an exponent, the only way it can join with something is if it has another base that's the same. So like, if this was 4 to the something times 4 to the something, I could put them together. We agree? But what you cannot do is you cannot multiply these together because the 4 has an exponent. So I'm not allowed to multiply the 2 over and say it's an 8, which all of you will do. And if you're someone who's like, I'm totally doing that, you should write a little note to yourself and say, I cannot multiply these together. Okay? So, you're going to times that. You have this one still, right?
Yeah.
Okay. Mrs. E, there's more notes. Can you grab them off the photocopier? Page like 7 onwards, once we get to this. But anyways. Instead of multiplying by the 2, what could we do?
Convert the 4 to the x plus 2 to 2.
We could. What else could we do? No, what else could we do with that 2? We can't multiply it to the 4, but I could do what to the 32 with it? Starts, yeah. You can divide the 2 over. Why can I divide the 2 but can't multiply it by the 4? The 32 is just a 32. Can I do the number 32 divided by 2? Is that something we've learned in our whole lives? We can do the math of that? Yeah. 32 divided by 2. 32 doesn't have an exponent, so I can divide these. 32 divided by 2 is 16. We've learned in real life we can do 32 divided by 2, right? We just can't go 2 times 4 because the 4 has an exponent. So now I have 4 to the x plus 2 equals 16. Now what could I do to these 2? Yeah. Make the 16 be base 4, right? We're always making them be smaller bases, Caleb. We're always making them be smaller bases. So 16 is 4 to the what? 4 to the 2. So we get 4 to the x plus 2, and 16 is 4 to the 2. Now what can we do if we have the same base? Set the exponents equal, right? Because if we have 4 to the something equals 4 to the something, then those somethings must equal. So I have x plus 2 equals 2. Subtract 2 from both sides. And x equals 0. You try I. That's the first thing we should do. Okay. Lauren?
Divide 9.
Divide by 9. Can I do 9 times 3 and make this be 27? Then they're the same base and life is good. No. So I'm going to divide by 9. And I get 3 to the 2x plus 1 equals 3 to the what? I need an exponent on this 3.
1.
It's a 1. Any number that doesn't have an exponent, you can put a 1 on it, right? Now, if you have 3 to the something equals 3 to the something, what can we do next? Make the exponents equal, though. Some things have to equal, right? So we get 2x plus 1 equals 1, and then what can we do? Minus 1. And we get 2x equals 0. Then we divide by 2. What? And x equals 0. What? Any number that doesn't have an exponent, its exponent is 1. If you put a 2, 3 squared is 9. If you put a 0, anything to the power of 0 is what? 1. So what exponent are you going to put on it?
I feel like I am not confident in explaining why I did what I did, so I'm going to let you have it. You win this one.
Is your answer 0?
No, it's 1.
Okay, then you're going to have to let me have it, because yours is 1.
I know. That's why I'm letting you have it.
Did you put it to the 0?
No, I put it. I don't even.
You put it to the 0.
No, I put it to the 3. Like 3.
3 to the 3.
3 to the 3 is 27.
Except you went 27 divided by 9, which is 3. Yeah. Cool. Good talk. All right. We're going to move to the next page, which I don't know if you actually have it. Okay. You start on 2 pages from now. All right. So we're converting between logs and exponentials. And the reason why we need to know this is logs and exponentials are a unit exam where the unit is written together, because you need logs to solve exponentials and exponentials to solve logs. Because if you can't make something a common base and it's an exponential, you can't solve it exponentially. You have to convert it to a log. So what does that mean? If I gave you like 2 to the x plus 3 equals 5, can I make 2 and 5 be the same base? No. So do I just sit there and cry and say, I don't know how to do this? No. What you're going to learn today is you're going to learn to convert that to a log, and then you can. Because when you convert any exponential to a log, what it does is it takes that exponent that has your variable. When you have a variable in the exponent, it takes it and it brings it down and makes you solve it like normal. Up here, I don't know how to get that to drop down. How do I get an x plus 3 to get gone? So I'm getting x by itself. I can't. So if I can get that x plus 3 to come down and be like x plus 3 equals something, then I can work with it. Then I know how to do that. I can subtract the 3. I can solve for x. Life is good. Okay? So if you're asked to solve an exponential and you cannot make it common base, the way to solve it is by converting it to a log. Well, how the heck do we do that? Cool thing is, this is on your formula sheet. This formula is on your formula sheet. And this is where I lose people. Like you're lost in like Narnia or something. So what you need to remember is, in order to convert between each of them, you need to have, if it's a log, you put a log underneath. If it's an exponential, you put an exponential underneath, is the key thing. But what you're doing is you're literally just moving variables that are on this one to a different spot for a log, and variables that are on this one to a different spot for an exponential. So if we look up here, my x is in the variable, which is not helpful, correct? That's what we're saying. Like, I'm trying to make you solve an x that's up in the variable, a variable up in the exponent. How the heck do I solve that? Well, when you convert it to a log, look where it moves to. Right beside the equal sign, and then I can work with it. It moves it down. It moves it out of the exponent. With logs, when you have something beside a log, how the heck do I get this by itself? Well, I can't. But if I convert it to an exponential, it actually gets it by itself. So converting back and forth between the two makes it so you can actually solve an exponential or solve a log by using the conversion. So for here it says, convert the following logarithmic form to exponential. So I want to convert this from a log to exponential. So am I converting from a log to exponential or an exponential to a log? Which one? I'm going from a log to exponential. How do I know? Because it has the word log. It's a dead giveaway. Look at that, log, log. And then I'll have you guys lining the exponential under the log, and I'm like, not good. Okay? So if it has the word log, I'm going to line the log equation up with it. Okay? What is the log equation? It is x equals log base a of y. Do you see that? And I'm going to line it up with this one. How? Well, log is log. 7 is what? A, right? What is x actually? This word gets confusing. X is actually y. And then 4 is in the spot of x. Right? And now I'm converting it to an exponential equation. What is the exponential equation formula? What does it say? It's one without a log. Y equals a to the x. Correct? What is the y? X. What is the a? 7. What is the x? 4. Done. So I'm legitimately lining the log up with the log, the variables up with the variables. If a log doesn't, so if a square root doesn't have a number on it, an index, it's a 2. We all know that, right? You've been taught since you were little. Square root without a number is a 2. If it's anything else, it'll have a 3 or a 4 or a 5 or a 6 in the index of a square root. Today you are learning that if a log doesn't have a base, this one's base was base 7. Do you see that? If a log doesn't have a base, it is base 10. So, does this log have a base currently? No, so I'm going to put a 10 there. So every time my log doesn't have a base, I just go put a 10. Then we're lining them up. Log, log. What is this going to be? What is the 10? A. What is the x? What's beside the log? Y. And then what's by itself? The 4, which is the x. You're literally just lining up the formula, right? So I use the log formula, so what am I going to put it into? The exponential, this one. So y equals a to the x. What is y on this one? X. What is a on this one? 10. What is x on this one? 4. Done. Okay, let's look at C. Remember, we're lining up logs. So we're lining up the log equation. The log equation is x equals log base A. That is bad, it's right over. X equals log base A of y. So I lined it up with the log, right? Log, log. What is the 5? A. What is the 15? Y. What is the y? X. Then I'm filling it into the exponential, which is y equals a to the x. So what goes in for y? 15. What goes in for a? 5. What goes in for x? Y. Done. Let's try D. We're lining up with the log. We're lining up with the log, right? So this is our log equation right here. Oopsies. So right now we're going from log to exponential, right? So we're lining it up with the log equation. So So I have log, log. What's beside the log? What's the t representative of? A. What's the b representative of? What's the n that's by itself? X. What formula am I putting it into? The exponential, which is y equals a to the x. It's just a conversion formula. Yep.
When you have like a letter in the place of the a, so in this case the t, do you put 10 in its place?
Nope.
You just leave it as t?
Yep. It's only when there's literally nothing there. A variable still counts as a variable. Number is good. It's when it's like only like this one, where there was absolutely nothing in as a placeholder. Yeah, good question. So what's y? B. What's little a? T. What's x? Done. When you're done that one, put your pencils down for a second, because I'm going to do the next one wrong, and I don't want you to write it down. So this one, I line the log up with the log, I line the a up with the a, I line what's beside it up with y, I put what's beside it with x, and then I have a leftover 3, and I'm just going to ignore it, put it nowhere, and hope that I'm right. Could I do that? Can I just take a number that's there and be like, meh, they mustn't have meant to put it there because I don't know what to do with it? No. So I need it to go away because currently I can't use it how it is, right? So I should have never went a, y, and x yet. I should have never lined it up with the formula yet because I have 4 pieces of information and I only am allowed to have 3 to convert. An a, and an x, and a y, right? So what could I do first before I try and line up the stuff? Because I need to get that 3 to get out of my life. Anyone have any ideas? Yeah. You can just divide this side by 3. That's an eraser. You can divide this side by 3. Divide this side by 3. Can I do 9 divided by 3? Is that a real thing in life? Yeah, in grade 3 you're allowed to do 9 divided by 3. So in grade 12 you're still allowed to do 9 divided by 3, right? So now I have log base 4 of x plus 2 equals 3. Now you can write this. So now we're going to line up stuff. Now we can line up stuff. We have 3 pieces of information. A y, an a, and an x is what I need. So I line it up with the log, and we're converting it to the exponential. So log, what's beside it is what? A. So the base of the log is a. What's over here beside the log is? And then what's by itself is? X. And then we're trying to convert it to exponential, so I'm going to have y equals a to the x. So what numbers am I going to get? What's my y? X plus 2, and my a is, and my x is, and I'm done. What's this? Your turn. And we're going to go through them quickly, no dawdling. So we're going to line them up. We have log, and then we always have base a, y, and what's by itself is the x. So this is a, y, x, and then we get in the form y equals a to the x. So we get y is what? X, a is, and then it's to the power of. All right, then we have log base 10. What do I have to do first, though? Divide the 3 over. So I get 3 equals log base 10 of x. If you forget to do the division, you'll catch yourself because you're going to have a number that has no variable correlating to it. And you'll be like, we did this before. What did we do? Okay? So then this is going to be log base a. What's beside it is y, and what's by itself is x, because it's x equals log base a of y, which is written above, but you can't see mine. So we get y equals a to the x. So we're going to get x equals 10 to the 3. This one we get log base a y equals x. And so we get y equals a to the x. And so we're going to get 27 equals 3 to the y. This one we have log base a of y equals x. And so we have y equals a to the x. So it's c equals x to the p. What do we do with j? Divide by 4. So we get log base 4 of 2x minus 1 equals 4. And then we get log base a y equals x. And then we get y equals a to the x. So we get 2x minus 1 equals 4 to the 4. Done. Doesn't ask us to solve for anything right now. It just says convert. Right? That's all we're doing. So we can convert from log to exponential. What about exponential to log? So some people will try and line the log up with this. Is there a log word in here? No. So would lining the log up help? No. We're going from y equals a to the x. We're going from exponential. This is called an exponential. And we're going to a log, which is x equals log base a of y. The cool thing to check is the base of both of them, the base of the log and the base of the exponent are the same. Like a in both cases, right? So I know at the very least, this 4 is going to become base 4 on my log, because the bases are the same in the exponentials and logs, the others switch. So I need to line these up. So this is my a, because my base is my a, right? I don't know how that just changed colors on its own, but that's impressive. And then, am I recording? Squeeze that if I'm not. I am. And then the exponent is x, so this becomes x, stays the same. And what's by itself is the y. Changed again. I'm a miracle worker. I'm not even touching the board. I think it's, if it thinks that it's like a thinner tip like this one, then it turns it. Anyways, we're going to change this to log. So we're going to change it to x equals log base a of y, which is the formula. And now we're going to input it. What is my x? X. It was actually nice. Log, what's my base? 4. Do you see how the base of my log and the base of my exponent are the same things? Which is nice. And then y goes beside it, and what's y? 64. And always put what's beside a log in a bracket. Makes it helpful. So then here, we line up again. What's by, or the base is the base, right? So the base is a, so I go to my base and I make it an a. Its exponent is x. And then what's by itself is y. And then I need to now write the log equation. X equals log base a of y. So I'm going to get x plus 2 equals log base 3 of, what do I get? What's y? 20. What's my problem with C? Can I make that 3 and that 5 join and make it a 15? No, because the 5 is an exponent. So instead of choosing that route, which is wrong, what route should I choose? Divide the 3 over. So I get 5 to the 2x minus 1 equals 4. And then I have to line it up. Remember, the base is the base. So the base is a. So the base of my exponent is a. Then what's in the exponent is x. And then it equals y. And then I write out my log equation. X equals log base a of y. So I'm going to get x, which is 2x minus 1. Log base 5 of 4. We're skipping D. Now we're moving to Your turn. Go. Then we're going to do some solving. So we have a x, y. So then we have x equals log base a of y. Just to clarify, which Spencer asked, which was brilliant of her to ask. Those are in the same line. Like if I drew a line, log and y are the same height. And then a is a little subscript. Does that make sense? Mm-hmm. So y isn't actually an exponent unless y had its own exponent or something in it. Good question. So this is going to be x, which is 2x, equals log, and what's base a? 5, and then at the same height as log would be 125 in brackets. Thank you for that question. That was a really good question. Okay, this one is a x, y. And then I get x equals log base a of y. So I'm going to get 3 equals log base x of 36. It's really hard to make your brain sometimes work it around it when it has x's in it, and then you can't put the x in the x spot. This one we have to divide the 4 over. So we get 9 to the 3x minus 1 equals 6. Then you line them up. A, x, y, x equals log base a of y. So we're going to get 3x minus 1 equals log base 9 of 6. And then for h, we line up base with base. So a one is x equals the y, and then x equals log base a of y. So I'm going to get b equals log base d of x. So that's just a plain old conversion. And on the diploma they will give it like a plain old conversion, just convert. That's it. Then they'll also ask you to solve, which is the next page we're going to flip over. Solve. Well, hello there. Little algebraically solve. Didn't see that coming. This is my favorite lesson. You may not like it, but it brings me great joy. This and common base. Great joy brought to me. Like it's like a day I like to exist as a teacher. Transformation unit in 30-1. Don't really like existing as a teacher. Everyone finds it really hard, but I like it. But that's exactly it. Yeah. So today though, love it. All over this. So why do we have to convert this to exponential? It says it's a log. Can we not just solve it as a log? No. Because the x, if the x is locked beside the log, do you see how it's locked in there? How the heck do I get it out of there? I don't know. If the variable you're looking for is locked in the base, how do I get it out of there? Do I like 1 over b it? Like, I don't know. You can't. You can't get it out of the log if it's sitting beside the log, and you can't get it out of the base by doing normal bed mass. There's no amount of bed mass that will get this x out of the log and that will get this b out of the base. Okay? So if your variable's beside the log and it asks you to solve, or your variable's in the base and it asks you to solve, you immediately have to convert it to exponential. Okay? So is this beside my log and is it locked in here? Yes, so what's the very first thing I'm going to need to do? Convert to exponential. So when I line it up, so my conversion formula is y equals a to the x. It's a double-headed arrow because it means I can convert back or forth. X equals log base a of y. Is this a log or is this an exponential? A log. So I'm going to line it up with the log, correct? And log, I'm going to line it up with the log, and then I'm going to convert it to exponential. So I have log. What's this 6 going to be? A. What's beside the log? Y. And what's by itself in this equation? X. And I'm going to convert it to the other one, so I'm going to write the other one out. Y equals a to the x. Now, what is y in this case? x plus 3. And it equals a. What's a? 6. And what's x? 4. Can I now do this math? Is this math I can do? Yep. Is the x locked in anything that I can't do? No. So 6 to the power of 4 is a large number. It's 1,296. And then subtract 3. Now you can check these by plugging them back in, right? You could go log, what's the check? Log base 6 of 1,293 plus 3 equals 4. How in the heck do we put that into our calculator? Well, if you have the new calculators, welcome. If you have the calculators with an exponent that pops up, you can throw a little party. If you have the older ones, you'll be fine. You just have a little extra steps. Okay? So if you have the new ones, you're going to press math, and you're going to arrow up. You're going to press math, and you're going to arrow up to the log base one. I don't have any of the new ones. I have the old ones. Math, and you're going to arrow up. Yeah, I'm just wondering what number it is. A. Okay? So you're going to go math, you're going to arrow up to A. You could arrow down all the way to A, it just takes you longer. And then it gives you the spots to put in these numbers, right? You're going to put base 6, and then in the bracket, you're going to go 1,293 plus 3. And you should get an answer of what? 4, right? And 4 equals 4, and we're right. We've checked it. If you have the older calculators, you do not have the log base button. If you have the older calculators, you're paying attention right now. You have log base 6 of 1,293 plus 3. You have this. If you have the old calculators, you don't have a log base button. So what you have to do is actually type the top in divided by log of the base, log 6. So you type in log 1,293 plus 3, close bracket, divided by log of 6. Now this works for every single calculator. It's just more work. But every single calculator can do this one. The short way, only the new ones can. Okay? What about B? Is the B locked in that I'm trying to solve for? So what am I going to have to do? Convert to exponential. I have no choice. So log B is actually A, Y is actually 144, and X is 2. And then I write up my equation. Y equals A to the X, and I get 144 equals B to the 2. How do I get rid of the 2? Yeah. You square root both sides. Whenever you do this square root symbol, when you do that motion, you have to put plus or minus. So B equals plus or minus 12. There is a problem here, just so you know. The base of the log and what's beside the log can't be negative. So if your variable's in the base or your variable's beside the log, you can't have what's beside a log or in the base be negative. So actually B equals 12 is the correct answer. And if we want to, we can actually say B equals negative 12 is what? Extraneous. Really switching colors on me today. Look at this. Now just stop. It's colorful. It's doing what it wants. It's writing. I don't even care. Okay. Your turn. Your turn. Yeah. You know. So this one, when this one converts, it's going to be b to the 5 halves equals 24. And Mrs. Z taught you when you guys were reviewing how to get rid of 5 halves. You're trying to make that be b to the 1, correct? Ultimately, in the end, b to the exponent 1, which means I don't have to write an exponent, so it would just be b. How can I get 5 halves to turn to 1? That didn't make it any better. I raise it to the power of 2/5. Because 5 halves plus, or times 2/5 is 10 over 10. And what's 10 over 10? 1. So this will cancel off. And then what I do to one side, I still have to do to the other. So you'll just go 24 to the 2/5. I don't know why this marker's done with me. It literally just wants. So you'll get a decimal, 3.565. Okay, so you're finishing these ones off for tomorrow. E, F, G, H, I, J. I'm posting it in Google Classroom. You need to finish it.